Welcome to lesson number 36, Elements and Compounds. We're getting near the end of the chemistry unit. You have learned about the periodic table, how to draw Bohr diagrams. You know the different families and their properties. You understand that some things are more reactive and other things are less reactive. Now you get to try and mix them together. And realistically, when you do chemistry in the future in high school and further, this is really what you're talking about. The stuff we've known before is just the basics you need to know before you can even really play the game of chemistry. Now we're getting into it. We're going to talk about how things bond together and stick together, whether they use energy or give off energy later. So now we're really getting into the grit of chemistry. So you should be on this slide. I've included it in the Google Classroom, but you have a beautiful copy down here as well. No problems there. You should have that. All right. Elements and compounds, and that's where you get these weird looking molecules kind of built together. All right, let's go to the first slide. An element is a substance that's made up of one kind of atom only. Here we've used orange circles. This is one type of element, and these are atoms of that element. They're all the same. It cannot be broken down into simpler substances. There's not like squares or rectangles in here, right? So this is an imaginary element. It's got atoms of that element. It's pure. Only one kind of atom in it. Okay. There's another kind of element made up of atoms of just that element. I think you could see where we might go with this after, right? But that's pure. There's no other things in it. It can't be broken down into anything more simple than that. It's just all types of atoms of that one type of element. Imaginary element square and imaginary element circle for now. You'll understand soon. All right, that's down here. Here we go. A molecule, when two or more atoms of the same kind join together, chemically we call it a molecule. And a compound is a substance that's made of more than one kind of element. So a molecule is like a whole bunch of copper or a whole bunch of gold. But a compound is like copper and carbon or something like that. Something mixed together. A compound is a substance that is made from more than one kind of element. It can be purified and broken down. So let's take a look here, right? That would be a compound made up of two different elements. Lots of things are a compound. For example, water is a compound. Water is made out of hydrogen and oxygen together. It's a compound. So you can think of this as a compound. Two different elements, atoms, combined together. They like to react. They like to stick together, these two. We'll see why. Okay. Ooh, look at that compound. A compound made up of 7 different elements. Now that's a complex compound. That's pretty cool. But you can see all different kinds of atoms all bound together. This is just an abstract for now. We'll get down into some real examples right away. A compound can be broken back down into its elements, right? So you could take all the circles there, all the blue circles, and all the green squares. So you could see there is multiple atoms from different elements that were, if I go back, in that group, right? So now let's take a look at this. Water is made up of hydrogen and oxygen. Is it a pure element or is it a compound? Well, since it's made up of two things, we would say it is a compound. Coal is just made out of pure carbon. That's just a pure element. It's just a fancy name for it. Carbon dioxide means there's carbon and oxygen, so that's got to be a compound. Oxygen is made out of pure oxygen, so it's an element. Chalk is made out of calcium, carbon, and oxygen. Guess what, folks? That's a compound because it's made out of multiple things. 2 things, compound. 2 things, compound. 4 things in caffeine to make it up. It's a compound as well. Elements are pure. They're only made out of one thing. All right, and here's some more here. Let's just go through that. Water is a compound. Oh, there's your answers. Sorry. Now, let's take a look here. A pure substance contains only one kind of particle. A mixture contains at least two different pure substances. They can be homogeneous or heterogeneous. Homogeneous means they're all the same, or heterogeneous means you have different parts mixed together like a pizza. Let's just take a little bit of a look at this, okay? Chemical formulas. When atoms combine together, a chemical formula tells us how many are each atom or element is in that compound or molecule. So when atoms combine together, a chemical formula, this is a chemical formula, that's a chemical formula, that's a chemical formula, and they all tell us how many of each element is in this compound. All right, so let's take a look. How many carbons are in this? 1. How many oxygen? That's 2 oxygen. 2 hydrogen and 1 oxygen in that one. What about this one? Na is sodium, so there's 3 because that's one compound, right? Sodium, 3 sodiums. So sodium, I could say 3. So let me get my table here. And how many phosphorus? 1. And how many oxygen? 4. Okay. Now, there's different kinds of compounds. There's some where we share our electrons, and there's some where we take electrons. There's ionic compounds, and there's covalent compounds. And you'll have some reading on that today that really does a great job of laying it out for you. So let's just take a look. So there's different kinds of compounds. Let's look at an ionic compound. So when a metal and a nonmetal combine, it's called an ionic compound. Remember, when a metal, which gives, and a nonmetal combine, so if you look, you can look and you could say, is this compound ionic? And you could see, is it a metal plus a nonmetal? You could look at your table. You know that metals are here and nonmetals are there. So if you see this combining with that, something from here combining with something from here, ha-ha, it is an ionic compound. Just by looking at the table, I've deduced that. Now, the metal gives its electrons to the nonmetal. And when the metal gives away the electron, the nonmetal gains electron, so they're attracted to each other. What does that even mean? Well, let's see. Let's do an example here. All right. So lithium and what? Lithium combining with fluorine. All right. So we'll draw a diagram of lithium, right? Lithium. How many protons? Protons equals 3. Neutrons equals 7 minus 3 equals 4. I put that in the nucleus. Then I draw one ring because I've got to get rid of 3 electrons. And then I draw another ring. Okay, and it has 1 electron. Now I can draw fluorine down here. Fluorine has protons equal 9. Neutrons equals 19 minus 9 equals 10. I have to put 9 electrons in rings. So 1, 2, and then I can draw the other 7 in the next ring. 3, 4, 5, 6, 7, 8, 9 electrons. And this one will give its electron so that this shell gets eliminated because it loses it. And this shell now gets a full amount of electrons. And they now want to stick together. The metal has given to the nonmetal. This is an ionic compound now. LiF. Cool. All right. What about aluminum and chlorine? Okay. Well, where do we see? We see chlorine right there. Cool. And we're looking at aluminum there. Metal giving to a nonmetal. So let's draw aluminum first of all. Aluminum has 13 protons, and 27 minus 13 equals 14 neutrons. So I have to draw 13 electrons. 1, 2, the next ring, 3, 4, 5, 6, 7, 8, 9, 10. This one has 1, 2, 3 in its outer shell. Now what about fluorine? Fluorine here. Fluorine, I'm just going to draw it over there. Fluorine has 9 protons and 10 neutrons. So I can draw 1, 2, 3, 4, 5, 6, 7, 8, 9. How many does it need to make a full shell on the last ring here? It only needs 1. But this aluminum has 3 it wants to give away. So it can give 1 here. Then we have to add another fluorine. We could draw another fluorine there, and we could draw another fluorine here. And this electron would go there, and that electron would go there to this fluorine, and to this fluorine. And the formula now would be AlF3, because we need 3 fluorines to take all the electrons that the aluminum gave. So it bonds in a 3-to-1 ratio, because this has 3 electrons in its outer shell it wants to give, but this one only needs 1, this one needs 1, this one needs 1. That's pretty wild. If you want to look up ionic and covalent compounding videos on YouTube, you can for more diagrams and animations. That's okay. Now, covalent compounds is not where one steals the other, it's where they share. Co means cooperate or share. Valent means valence electrons. Covalence, sharing valence electrons. When 2 nonmetals combine together by sharing electrons from their outer shell, we have what we call a covalent compound. So we've got carbon and chlorine. See, because carbon is to the right, and so is chlorine. So they're not going to rip. It's not going to give and take. They're going to share. Now, a covalent only happens when things from this side merge together, because they can't give anymore from here. They have to share. So carbon and chlorine. How would we draw that? Let's get our booklet out here. Oh, that got cut off. My bad. Okay, carbon. How would we draw carbon? Carbon we have here. So I'll draw carbon first. Carbon has 6 protons, 6 neutrons, so I have to draw 6 electrons. 1, 2, and then in the next shell, 1, 2, 3, 4 ready to go. How many does it need to fill this up? It would need 4 more to jump in to make a full ring, because this ring can handle 8. So it's got 4 valence electrons. Okay, let's look at chlorine. Chlorine is a little bit different. Chlorine, as we know, has 17 protons, and 35 minus 17 is 18 neutrons. Now I need to draw my rings. I put 17 electrons, 1, 2. The next ring is going to be 3, 4, 5, 6, 7, 8, 9, 10, which means I can add 1 more ring, and I've got 7 I got to get rid of here. 1, 2, 3, 4, 5, 6, 7. It only needs 1. Uh-oh! What do we do? How do we share? So, what could happen is this chlorine molecule could share here. But we'd need to add another chlorine. And we could draw that whole diagram, and it would share a last one. We could add another chlorine here. It could share its last molecule. And we could add another chlorine here. And it would share its electrons, because this has 4 it wants to share, and this only needs 1 each way. So your compound would be Cl4. It's just easier to read that for Cl4C. 1 carbon to every 4 chlorines. Don't get too confused, because this is something we should be doing in a classroom. But you could try and work your way through these sheets and look at the bonds and Google, like I said, look on YouTube, covalent and ionic compounds and examples. So this is going to bring us to the next thing that you need to do. There's quite a bit of reading to do with some questions as usual. And I'm going to show you right now what you need to do, and then you could take pictures of all your answers and submit them to me for lesson 36. So the first thing you'll do is you'll read 2.1. right? And it's quite a few pages. And then you will do questions 1, 2, and 3 on page 47 of the book. You will then do 3.1, and you can read about compounds. And this is a very good handout talking about different kinds of compounds, right? Ionic versus covalent. So that's a better example maybe to show how they share. So if you're having troubles, this is a very good place to read about it. And on that section here at the bottom where it says page 75 in your handout, you're going to do 1, 2, 3, and 4. Okay, not so bad so far. Then you need to do a nice simple counting atom assignment that you take a picture of and you send to me. I can do a couple of these for you here. Let's do a hard one. Okay, well this one's easy. Let's do, how many magnesium are there? 1. How many oxygen? 2, because you got to multiply by what's inside. So 2 oxygen and 2 hydrogen. That's all you need to do. What about something like this? How many carbons? Well, there's 7. How many hydrogens? How many nitrogens? 3 times. And look at this, there's 2 oxygens in the bracket multiplied by 3. Whoa! Now, the hardest question on the page I'm going to do for you, just so you get it. All right, look at this one. This is a wild one. Cellulose. Remember, that's the outside of a cell wall from the biology unit. Kind of cool. How many carbons? There's a carbon. Okay, carbon equals 6. How many hydrogens? Uh-oh, there's 7 there. Plus 3 there equals 10. How many oxygen? Well, there's 2 there. But there's 3 times 1, so there's 2 plus 3 equals 5. That one's a little complicated, so you just do the counting atoms. And I've also given you this sheet that you can do, where you could talk about bonding basics. Now, this is something you could do for yourself. You don't need to take a picture of this one. But you can work your way through it and draw the bonds and do your best. Now, this, if you can do this, you are doing great. This is hard to grasp in a simple video, but if you can do this, you're doing great. And the answers are on the back for that sheet for you to check. And if you could do that, you are in excellent shape. If not, don't stress, because this is more a one-on-one kind of thing. But I'm trying to give you a basic outline of what you could be doing. So that has been the unit on elements and compounds, or the lesson. And coming up next, we're going to do physical and chemical changes. And then we're on to the review. So great stuff. Take pictures of all your reading and your counting atom sheet and submit them to me for lesson and assignment 36. And we'll be moving on soon. Take care.